No, I didn't. Hey, Casey and Sienna. This is the second half of R8. And we got 4 examples to do. So starting with example 6. They're doing inequalities this whole section, but we're doing absolute value inequalities, okay? All right, so let me just explain to you what this means, right? The absolute value being less than 3, here's what this means. It means that I want to know the distance that is less than 3 away from 0. So that would be all of this group right here, okay? Less than 3 units away from 0 would be from -3 to +3, open circle, because it's not equal to, yeah? If I want to be greater than 3 units away from 0, it's going to be open circle this way and open circle this way, okay? All right? I'll show you what to do when you start to do the algebra of it and you don't even really have to think about it, okay? Ready? Good? Okay, hold on. So here we go, example 6. We're starting with this guy, and we've got to do some things before we can even start our cases, right? What do we got to do first?
Add the 3 and divide by 2.
Yeah, we got to get rid of the 3 and the 2. So I'm going to add the 3. Okay. 2 absolute value, 6 minus m, close absolute value is less than 10. And then I'm going to divide by 2. Okay, I got to isolate the absolute value first. Is less than 5. There we go. Got it? Okay. Good? Now, 2 cases. Here's where the cases get a little bit weird, okay? My first case, 6 minus m is less than 5. Done. That one's nice and easy. And then you have to solve, obviously, okay? But my second case now, I flip the signage in here, okay? But let me show you what's going to happen, all right? So if I flip the signage in there, that would be -6 plus m is less than 5, okay? A lot of people like to, instead of distributing the negative through like this, okay, instead of distributing that negative through like I did here, they like to divide by a -1 to begin with, and then I have 6 minus m is greater than -5, right? So I can flip the sign and make that a -5 instead of a +5. Got it? Now, in this case, I prefer to do the first one because it makes my m positive, right?
Otherwise, you're going to have to flip the sign.
But sometimes it might be easier to do the other way where you flip the sign and make just the number negative. Got it? So I'm going to keep it this way, but there's that. Got it? Okay, so I'm going to subtract my 6 over here. -m is less than -1, and if I divide by -1, m is going to be greater than +1. I flip my sign, right? M is greater than 1. There's that. Okay, now this one I'm just adding the 6. So m is less than 11. Are those going to be together or apart? Together, because 1 is here and 11 is here. Open circles on each one, right? Greater than 1, less than 11. It's going to be that little guy right there. Okay, so there's the graph of him. And you can put them together. So 1 is less than x, which is less than 11. You can write it like that as well. Some people like to do it that way. Okay, and then that is 1 comma 11 paren. So this is interval notation, set builder notation, and the graph. I don't know if they asked for all of them. They just asked for interval notation. So there is that. Good? Beautiful. Okay, sure. All right, good? Questions? Moving on? All right, what first?
Divide by -2.
Divide by -2. Makes him go away there. And this is +2, but I have to flip the sign. Less than or equal to, absolute value, 3x plus 1, and now I can start my cases, right? First case. 2, less than or equal to, 3x plus 1. Okay? Second case. 2 is less than or equal to -3x minus 1, or -2 greater than or equal to +3x plus 1. So I flipped the sign and I bummed the negative over. That's what I want to do it that way this time, right? So that my x is positive. Make sense?
Yeah.
I go back and forth. Sometimes I'll do it one way, sometimes I'll do it the other way, right? Okay? Oh, and that was case 2. I forgot to write a 2. Okay? So let's solve this guy. I'm going to subtract my 1. So this is 1 is less than or equal to 3x. If I divide by 3, we get not nice numbers. X is greater than or equal to 1/3, or 1/3 is less than or equal to x, right? Then I'm going to subtract the 1 over here. And -3 greater than or equal to 3x, and I divide by 3, and x is less than or equal to -1. Okay. If I graph him, Negative 1 goes here. 1/3 goes here. They are
Separate.
closed circles on each one. Right?
Yep.
Closed circle, okay? And
They're together.
we're going, no. We're going less, x is less than negative 1, and x is greater than 1/3. So he's going like that, okay?
Write it backwards.
I know, I should write him forward. Here, if I write him forward, he says this. X is less than or equal to negative 1, and x is greater than or equal to 1/3. And if I'm going to write it like that, my interval notation will be, what's the first interval notation? This interval notation. Negative infinity to negative 1, paren, bracket,
Bracket.
1/3
union with,
infinity.
bracket, 1/3 to infinity, paren. That's what this looks like in interval notation. If you have two pieces, you'll put a union in between them. If they're together, like the last one was, you'll just write it as one piece, right? And you won't have any infinities. Questions about that?
No.
Not terrible? Okay. All
Special case
right, all right.
That's-
Special case solutions.
Mm.
Okay, okay. All right, here we go. Special cases. All right, pay very close attention when you have absolute value stuff going on. Ready? I want to know, I'm not even looking at numbers really. I want to know when the absolute value of this stuff will be less than negative 4.
You can't.
Whatever this is inside of here, as soon as I take the absolute value, this will end up being a positive number, true? So it will never be less than negative 4, right? Because numbers less than negative 4 are only negative. So x has no solutions. So you just put no solutions, right? Do we see why that's a weird thing?
Yeah.
Yeah? Okay. Other weird things.
Travis.
B. I want to know when this thing will be greater than or equal to
It won't be.
negative 4.
But it can be greater than.
When will it be greater than or equal to negative 4?
0. When it's above 0.
Well, it'll always be greater than.
This thing is always going to be greater than or equal to a negative 4. We don't. It's never gonna be equal to, but it's always gonna be greater than negative 4, right?
So he's.
So x is
Oh, really?
all reals. I can plug whatever I want to in there, and it will always be greater than or equal to. Don't let the equal to thing screw you up, right? If I get the answer right here comes out to be 11, is that number greater than or equal to negative 4?
No.
Yes.
Yes. 11 is greater than or equal to negative 4. It's greater than or equal to negative 4. It's greater than negative 4, right? Okay? 11 is greater than or equal to negative 4. It's never going to be equal to negative 4. But the fact that it says greater than or means it's going to pass every time, right? Okay? Good? We see how that works? Okay. This guy, less than or equal to 0.
It could be 0.
Can it be less than 0?
No.
No, but can it be equal to 0?
X equals 0.
Yes. So he will only be equal to 0 if
X equals 5.
x equals 5. Okay,
Well, he could be positive.
x minus 5 less than or equal to 0. X minus 5 is
10.
greater than or equal to negative 0. Like is how you would set it up. Don't write this down. Don't write this down. I'm just going to see if this pans out, right? X is less than or equal to 5.
She's gonna confuse me.
Nope, that's not going to work. It's going to give you an incorrect answer if you try to do it with the two cases, right? Okay? All right, the only way of getting this, though, as an answer is if 0 is the answer. And the only way of getting 0 as an answer is if x is equal to 5. This is the only case where you're doing an absolute value or like an inequality, and you will get an equal for an answer. Does that make sense? Most of the time when you're solving an an inequality, you'll get like that same signage in your answer. This is the only time you'll end up with an equal, right? Yeah?
Yeah.
Okay, next. This guy, okay? This guy, D, what?
X has to be greater than
No, it could be another number.
It could be.
It doesn't have to be greater than 5. If it's 4, right? 4 is less than 5. 4 minus 5 is negative 1. The absolute value of negative 1 is 1. 1 is greater than 0.
So all
Greater
reals.
than 5.
Nope.
It's all real. It can't be 5.
Can it be all reals? What if it's 5 exactly? Will that be true if it's 5 exactly?
Less than negative 10, greater than 5.
No.
No, less than 0, greater than 5.
It can't.
Okay, let's talk about numbers, right?
You have to exclude 5.
Okay, let's talk about 5. 5 is the magic number, right? x minus 5 if y set them equal to 0, 5 is the magic number. Let's test a number over here, okay? Let's say we're testing -3. If I plug in -3 minus 5 is -8, positive 8 will end up being the absolute value. Is that greater than 0?
Yeah.
Yes, that's true, right? Let's test a number over here. Let's test, like, I don't know, 9, sure. 9 minus 5 is 4. The absolute value of 4 is 4. 4 is greater than 0, true. Yes?
So it can't be 5.
It can't be 5.
The only number it cannot be is
Positive.
5, right?
So X
Yeah, yeah?
greater
So
than 5,
X,
is less than 5.
I'm just going to say X can't be 5. X can be any number, but it can't be 5, right? Because it's not equal to 0 at that point, right? And that is also another case where you'll end up with like an equal to or not equal to, right? Okay, these are the only cases where you end up with not an inequality in your answer, right? Yeah, yeah? Weird things, okay? So, 2 things you need to be aware of. Beware. Beware. If absolute value of something, I'm going to just put whatever, is some signage, whatever, greater than or less than or equal to a negative number. I'll just put negative number. Beware, if you have an inequality and an absolute value involving a negative number, and I'm going to say or absolute value of something is greater than or less than or whatever, 0. So always beware if a negative number is on the other side of the inequality or if 0 is on the other side of an inequality, okay? Check those first because you're going to rack your brain solving it, doing both cases, doing all the things, and you're going to get to the answer, and you're going to be like, wait a second, I did too much work, right? Okay? So look for negatives, look for zeros. Got it? All right, number 9. I like this one. Shanice has test scores that are 96, 84, 80, 98, and 88. That's how many test scores? 5. Her score for online, these are test scores, by the way, so she has 5 tests. 5 of them. Her score for online homework is a 100. So homework equals 100 and is weighted as 1 test grade. Okay, so all of our homework together averages out to be 100, and that gets lumped in as 1 test grade. So now how many test grades do I have? 6, right? And I add all of those together, and it ends up like dividing by 6, and then I get an average, right? But now she still needs to take the final exam, which counts as 2 test grades. So now how many test grades do I have? 8, right? I've got a 96, I've got an 84, I've got an 80, I've got a 98, I've got an 88, I've got a 100, which is my homework grade that counts as 1, and then I've got 2 test grades, right? So I'm going to call those both X's, right? XX, because this is what my final test score looks like, right? Okay, so we're going to put a 2X, and we're going to divide by 8, and I want that to be at least a 90. So what symbol goes here? I want this part to be bigger than or equal to a 90, right? Okay, now we just solve it, right?
Yeah.
If somebody add all these together for me, would you?
Okay.
546.
Did you really? 546
But it has to be
plus
less than 100.
2x over 8 has to be greater than or equal to 90, right? Okay, and I'm going to multiply by 8. And this is 720.
Minus the 546.
And 546 plus 2x
Minus the 546.
minus the 546.
174, I think.
174.
174. Okay, and then divide by 2, and that is
67.
no, wrong. 87. 87, right? She has to get higher than an 87, but Zach also said she has to get lower than 100. We're assuming that 100 is the cap, so you could also add that in there, right? If you wanted to put it this way, 87 is less than or equal to x, which is less than or equal to 100, assuming the cap is 100. If there's bonus, this would no longer be true, right? Okay? So I'm going to go ahead and just say x has to be greater than or equal to 87, and that is how that works. Do we have anything else?
Nope.
This is the minimum to earn an A in the class, so she has to get an 87. You guys all do it, like not all of you do this, but I've heard Brady's come to me Eli definitely has come to me last year saying,
Final
hey,
grade
I don't
deadline.
have these 7 assignments turned in. How many assignments do I need to turn in to still get a blah, blah, blah? That sounds like a very Eli thing to do, true?
To still
Yeah, yeah.
get an A.
Yeah, to still get an A. How many assignments do I have to turn in? What's the bare minimum?
How many assignments do I need to turn in for Diane to stop yelling at me?
Right, exactly. Yeah. Okay. All right. Good. Happy with that? Yeah, yeah. There you go. Inequalities. Beautiful stuff. All right. Homework. Finish those last little bit right here. Those. There they all are. Okay.
Okay.
And then we are reviewing for the first chapter.
For our
Finally.
lab
No, we're
test.
not.
Woo!
Turn off your video.
Boy, stop.
Woo! Okay. All right. Bye, people watching this video.